I'm going to talk to you about a scary thing. So unfortunately I can't see you, so I shall do this once. How many of you are Java programmers? Good, you're in the right place. How many of you use Java serialization? Okay. Those of you who said you're Java programmers and you didn't put your hand up, you might be wrong. Right. So, me, Steve Poole, worked for IBM for a long time. Oh, that's nice. Mostly, I spent my career at IBM doing JVMs, and that's my life. But recently, I had the great joy of being asked to do more developer advocacy, so coming out and talking to people. So I get to talk about Java tech and not really write it so much. And that's cool, because there's lots of stuff to talk about. So this time I'm going to talk about Java serialization. We're going to talk about why it's important, because we do need it. We're going to talk about how the way that it's designed has some flaws. We're going to talk about how it gets how those flaws get exploited. And we even talk about who the bad guys are. And we're going to talk a little bit about how you can defend, which is a bit clunky, but there are things you can do. And I won't mention much about the last point. It's in there, and I'll mention occasionally. When we talk about Java serialization, a lot of the problems that you can see aren't just with serialization that comes out of the box. It's other forms of serialization that we've built in whatever language and in whatever form can also suffer from some of the same problems. So let's start with the most important thing. Why do we need serialization at all? Right? Because of this. So, it's a fairy tale, so there's going to be lots of nice fairy tale images. What do you do when you write Java? You create objects, you create graphs of objects. And that's all very nice and lovely. And then two things happen. One is you realize that you want to persist that graph, store it away somewhere, database, file system, whatever. And the other thing you go is, I'd like to share that data with another VM. And the problem is that getting from one VM to another, or from one VM to the disk, in a way that you can bring it back and share it, and you still keep your graph of objects, is complicated. And Java, when it first started, way back at the beginning, didn't have serialization in. And it was spotted pretty quickly that there was a problem. And it was implemented then pretty quickly. And I have to say, I worked with the guys in Cupertino when they were putting it in, and it was done really quickly with no real consideration at the time about some of the bad things that could happen. Okay, it was designed for flexibility. So it's very flexible, it's got a basic use case, and it gets used everywhere. Right? You may not think about it, but every time you use JPA, you put something to the disk, you quite often use serialization. If you've got Java code and you're calling out into the VM, however you do it, you're likely to be using serialization. Right? JMX, CDI, even in cookies. Some people take Java obgraph and turn it into this serialized form and stick it in a cookie and give it to the browser. And then the browser comes back and you deserialize and away you go. Which is a good idea, but could bite you, okay? And things like forms and REST services, it's used everywhere. A lot of the reason it's used everywhere because it's really easy, and it's other ways it's used everywhere because it's probably the quickest way to get your graph of objects into some form that you can store, share, bring back. So you can find it everywhere, and basically it's all about this thing, object input stream. That's the class that you use to bring back serialized data, right? So I went to GitHub and I searched. That's quite a few hits, isn't it? GitHub has a lot. So object input stream is used everywhere. Even if you don't realize it, the dependencies that you use, every time you go to your POM and update something, you might find that inside there is something that's using serialization, or its dependencies, or its dependencies. It's everywhere, okay? So how do you do it? How do you use it? Right, it's really easy. You just add this couple of words, implements java.io.serializable. You just opt in, really easy. Right? And then you want to save and restore object graphs, it's really easy too. There's a couple of classes that you can use. So you create an output stream, and then you wrap that in this object output stream, and you do write object of the thing you've got that's tagged with the serializable, gets turned into some form. And then you can put that form on a disk or send it to somebody else. And then the other person, or you later on, can do the opposite and use an input stream, an object input stream, and just read something back. Really simple, really easy, okay? Now in theory, if you don't opt in, and you try and write an object that's not serializable, you'll get an exception. You cannot do this. That's good, okay? You didn't choose to be serializable, so the system said, you can't save this. That would be a bad mistake, okay? So at one level, Java serialization is just really easy. It's very easy to use, save, bring back, share, exciting, okay? However, there might just be some things that are going to bite you. That's what we're going to talk about. So to talk about it, we need to look at what serialization actually does. Right? So here's the nasty start. So I have a class called OC1. The reason it's called OC1 is I did this talk at Oracle Code 1 this year, and I thought, if I'm going to change this for Java2Days, I've got to go through and regenerate all this stuff, and it's like, no, you won't mind. Okay. So, there's a class called OC1, implement serializable, has one field called hello, which has a content of hello, right? So, the second box, you instantiate that object, and you write it somewhere. And what you get is this byte stream, structured byte stream, okay? Let's walk through the structured byte stream. So at the beginning is, as you'd expect, some sort of magic number, okay, because that's so we know it's a serialized form. And then there's a version, again, so that the serialization code knows what version of the code was used to write this, so we can deal with those sorts of differences. Right. And then the first thing is a thing that says, what you're going to get next is an object. Which is true, because we've just put this object called OC1 down. Okay? And then it says, okay, next thing you get is the class description. What's the name of the class? Right? And that comes straight after with a UTF-8 class name. So UTF-8, in this case, it's length delimited. So the first 2 bytes are the length, tells you how many bytes are left that make up the name. Okay? Fine, so now we've got the name, and you can see oc1.serialization.oc1 in the right-hand side. Okay, good. Then the serialization version ID, which we'll talk about in a minute. Then there's some flags. Then it says, how many fields have I got to bring up off the data stream? So, of course, in this case, it's 1. And then it says, so what's the type of the first field? Well, it's an object, okay. And it says, what's the name of the field? Okay, you can see it's called hello, so I get it in the right place. And what's the class, not of the field, what's the class of the object that's going to go in that slot? And in this case, it's a string, because that's what we saved. Okay, some more flags. And then the string value, it says hello. Cool. So I don't know about you, but that's complicated to look at. So let's turn it into a table. It looks a little bit easier. So basically the same data, just structured differently. So I was going to talk about the serialization version ID, this thing here. This is important. You've probably seen it. Even if you don't use serialization, you probably had your ID moan at you because you didn't set a ver ID. The version ID is meant to determine that the class structure that you have available to you matches the class structure that was used when you saved the object. Okay? Because obviously, if you've got a new class structure and it's got new fields in it, or you've got less fields, then bringing data into that would be a mistake. Okay? So that's what it's there for. Cool. The interesting thing is the bit at the bottom, the first field, right? It says class name. It does not tell you anything about the type of the field in the object, in the class. It just tells you what I've got in this data stream, okay? So that's really cool. So it can be quite flexible. Okay, but there we are. Some magic numbers, and the class is hello, and the value is hello. Good. Okay. So that's good, right? You can take a set of objects and turn it into that byte stream, stick it on disk, and then bring it back. Or give it to somebody else and reconstitute it under the JVM and get the same object graph, okay? Pretty much. There are some edges, but they're not super relevant for this, okay? So let's go back to this. The actual contents of the instance are self-defining. This is where it starts to break down, okay? So look, I've got hello, JavaLang string, sorry, I've got a field called hello, class name JavaLang string, value hello. What happens if I change it? What happens if I put in JavaLang number, integer value 1? Okay, that's a valid byte stream as far as the deserializer is concerned, okay? So what it will try and do is it will try and instantiate a number and put it into the field in my object that's called hello, okay? If I do that, I get this, get the class exception, as you'd expect, okay? So it sounds like even if I do change the serialized form, serialization process will catch it, okay? So are we safe? Is serialization something that you can rely on to be safe? Well, it depends. So more examples. So I have this OC1 class that's got this field called string field called hello, and there are the basic bits that we care about, okay? Well, if I wasn't thinking and I had set my hello field to be type object rather than type string, okay, so it would look like this, okay, that still works, but it allows me, so if I take that, it allows me to replace the JavaLang object value with something else. So now I can put an array in, because it's still an object, and it will be successful, right? Or I can put a hash map in. It doesn't matter, because the slot, the field is an object, it could be anything. Okay, so I can change the data stream to put whatever I want in. Anything. Because it's self-defining, I can change the data stream and insert whatever data I want. Self-defining. So why is that bad? I wanted to put up lots of Disney pictures because it's a fairy tale. And then I discovered just what the level of copyright protection is on Disney or Disney images, and it's like, no, I'll go find some other ones, which is why they're a bit eclectic. Anyway, so why is the self-defining data stream dangerous? Well, let's try this. Look at what actually happens when you deserialize. So I have a class called foo, I have a static initializer, and an and a constructor, okay? What happens when you run new foo, okay? Well, you get two sets of output. You get the static initializer, cool, system.out.println static initializer, and you get the constructor called. Cool, excellent. That's what happens, that's what you expect to happen when you run Java, okay? Okay. What would happen if I play around with my data stream and I take that foo class that I've just talked about and try and stick it into that other class, which has got the string field. So I'm going to try and take my foo object, nothing that puts the output. I'm going to instantiate that and try and insert it into that class. Okay. Okay. So going back to the foo class, this is going to get created by this process. There are two things. Which of these are going to get called? Okay. So who thinks the static initializer is going to get called when I create this class using serialization? Okay, you can wake up. I won't answer the question. So which of these two are going to run? Well, let's see. All right. So if I use serialization to take that serialized form, which has got OC1 as the base class, and then inside the field it talks about the foo class, okay? this one here. Right? If I do that, I get the static initializer called because the class is loaded, assuming it's loaded for the first time, I get that data. And then I get an exception that says you can't put the foo thing into a space that's for a type of string. That's what you'd expect, yes? So A gets called, okay, but look, the word is instance. So during deserialization, static initializers get called, constructors don't. Okay? Constructors don't get called. It still fails, because any logic I have during a constructor does not get executed. Okay? And you may go, so it still failed, but the point is, even if it fails, code ran. Somewhere in there, code ran. And if code runs, the bad guys can use that to get your system to do things you weren't expecting. Okay? Look, if I've got this class, right, and I've got a foo class, and I've got a field called data as an array, okay, and I have a constructor that initializes it, okay, and a little field that tells me how big the array is. Okay, it's a silly example, but you get the point, okay? So what happens if I call, once I've instantiated, what happens when I call the size method? I'm going to get the length of the array, okay? If I serialize this object after I've created it and then deserialize it, what's going to happen? Well, as long as the streams doesn't get changed, that's what gets written. 1, 2, 3, 4. Okay? And when I bring it back, I would expect this to work. Because though the constructor didn't get called, the data's come up the wire and filled in the right places. Okay? So that's great. But if I go back to that stream and I change the data, so now I say, hey, it's going to be a null, right? When this object gets created, right, data never gets filled in because the constructor does not get called. So what happens down here? Data's null, you get MPE. So that's a really simple Mickey Mouse thing, but you can see that because constructors don't get called during deserialization, all your thoughts about how you validate that that object is correct could be wrong. If you don't understand that deserialization does that, then all sorts of bad things can happen, right? And it's not even just the classes that have implement serializable on, right? It's more than that. Look, 2 more classes, a parent class and a subclass. The subclass implements serializable, great. Parent class doesn't. Subclass extends parent. And there's some outputs, okay? Right. This thing just opts in the parent class into serialization. Parent class may not even realize that it needs to be part of serialization, but it's been opted in. So when you do new subclass, so you write some Java code and you create that an instance of that subclass, you'd get all this output, right? You get all the, I'm in the parent initializers, I'm in the subclass initializers, I'm in the constructors. Cool, great. On the deserialization process, though, I get the foo class initializer, I get the parent class initializer, cool, because you'd expect that. I don't get the message from foo because it doesn't get called, but the parent gets called. So now I can now make the parent code get called when maybe it wasn't expecting to be, right? And I've deserialized it. So you get these situations where code in your system may or may not get called depending on how it gets involved in serialization, okay? And this guy, the guy who wrote parent, right, he may have no intention to be involved in serialization, but he's been opted in because somebody subclassed it, okay? And you can go, okay, well that's not a big deal because I can track that, okay? But the trouble is you can have interfaces, right? Here's a simple, I have an interface called ifoo, and I have a class that implements that interface. Is the foo impl class serializable? Well, right now, no, because it doesn't implement, doesn't have is a serializable thing, right? But if the interface extends serializable, that class is now opted in. So again, if you rely on interfaces and somebody plays around with them, they can opt you into serialization, okay? So self-defining data streams are easy to manipulate, and your code will likely use serialization all over the place. And many of your dependencies will use serialization, you may not know it, and your code might get opted into serialization without you realizing it, okay? Java serialization is a really great gift to the bad guys. We didn't have bad guys around when we started doing this 20 years ago, but now we do, right? So it's a big deal while we have a talk. How many serialization vulnerabilities are there? Well, okay, there's never as many as you might think, but there's always some, okay? So you can go to this website, CVE list, and others, and you can get a list of the vulnerabilities. Here's, when I did this earlier this year, 24. There's the details, okay? A whole bunch of words, which basically says there's a vulnerability in serialization. Somebody has figured out how to make use of those weaknesses in the design to get into your system. Okay? And we'll look at that in a bit more. So, once you start thinking this through and you go, okay, so what can I do? What would I do in my application to opt out of serialization? What can I do? Right? Can we be safer? Are there things that you can do as a Java programmer that means you're more in control of what happens and you're being a bit more defensive? Well, the simple answer is there are things you can do, right? But it's a bit messy. There's a method you can add to your classes, okay, called readObject. It's a private method. It has to be a private method because if it's a public method, it overrides anything that's above it in the hierarchy. And we're talking about deserialization, so every instance in your object chain has to be involved, okay? So here's an example of where you might use this. This is a classic example. So you imagine you want to have a logging file, okay? And you want to save the config. You don't want to save the logging file, but you might want to save the config about where it's going to be. So you have a log file field, okay? And you have a transient file output string. So that's your logger. You're not going to save the log file. You just want to know where it is. So if you bring back this configuration, it just picks up. So a classic will be, readObject gets called by deserialization, okay? And it does that default readObject which says, populate me, please. And then your private method code then says, let's instantiate the output stream that's going to be my log based on wherever it is, okay? That's quite often you're going to do things like this. You have transient fields for data you don't want to share, and then you use readObject to recreate them, or whatever, when you bring the thing up from the disk, or when somebody sends it to you, okay? The trouble is, that's not safe either. Because people can do things like this. They can have serialization form that says, let's replace the value of log file that you thought you'd written with some arbitrary one, like etc password, or some other one. And what does that mean? It means that people, when your log starts writing, it doesn't write to where you thought it was going to log. It writes to some critical file, crashes your system, right, or does something more sophisticated, okay? So doing readObject is good if you put all the effort in, okay? All right? You can use it to basically opt out of serialization by doing something like this, by putting in throw exception, okay? You have to put this on every single one of your classes because it's a private method, all right? So you can't inherit it. You have to put it on every single one of them. And if you get it slightly wrong, it won't get called, and you may not know. Okay? So, that's sucky. There are other ways you can do this. There's some whitelisting things going on now within Java. There's some deserialization whitelisting where you can specify some filtering. What are valid classes, what are not valid classes, how big are you going to allow things to be, put some limits on it. But it's a pretty big stick to try and get you around the problem. So that's not the greatest. What you can do if you want to take control and have some even better control is you can replace object input stream. So you can write your own one. And there's some articles, this guy's got one, you can find it, where you can take complete control and write your own object input stream. So all the data that comes up, you get control of having to parse it. The problem with that is, object input stream is used in lots of places. Okay? We'll talk about that in a sec. So serialization is easy to manipulate, and it's hard to defend against. This is, the one that they talked to, which is one we'd say, if you're serious about it, you need to look at this. The good news is, we've now got things like modularity. Why does that work? Why is that better? Because if you think about what serialization is doing, it's trying to get you to run code you already have installed. It's all about that. So if you can reduce the scope of the code that's accessible, could you imagine I'm going to a serialization form and I'm putting in words, I'm putting in class names to try and make you run them. If they're not accessible in your class path or your module path, then they're not going to get picked up. So modularity in one level is really good to give you some compartmentalization and make it easier and safer for you. But really, the simple answer is don't use serialization at all. Start building protocol objects that you can use to move data around. Right? You can create simple Java classes that you can have fields and you can write them in a record type of things. You can do that. It adds to your overhead, but they're a lot easier to worry about because there's no code executing, they're just values, and you know how to deal with values. Right? Or maybe you don't use that at all. Maybe you just have something that moves your complicated objects into JSON or XML. Right? Maybe you could use some other things like Xstream or whatever. Maybe you could use some of those. Well, the problem with some of them is they're not as safe as you might think. This is just the list for Xstream, but that's just the example. All of the serialization forms that you pick, even would you believe, even things like JSON, have places that you can be exposed and can be forced into running code that you weren't expecting to. Okay. So it's hard. It really is hard to protect yourself against serialization. There's no hiding it. It's hard, right? But it's not just your code. It's all your dependencies. Okay? It's so easy. Right? We all use dependencies. We just install them, and you have no consideration about what they're doing under the covers. Okay? So, it's serialization, easy to exploit, if I can get into your system. It's about running code that you have, because I'm going to try and make you instantiate things that drive code, that do bad things, okay? Or maybe it's me changing your data, so your data will do, your existing valid code will go and do things that it wasn't intended to do, like overriding files and things. Right. So the real question is, how do they do this? How do the bad guys do this? Okay? Right. So let's talk about some of the data manipulation tech, okay? So how about this one? Serialization of data, denial of service attack. This is a nice little one. How do I get your system, can I bring your system down by changing your serialization data? Okay. Well, yes. We said you don't get involved in validation. Look, here's a serialization form that has a field that's of type as a data array. The element count, which would be something reasonable, what happens if I set it to max int? What happens when you're trying to instantiate an integer array that's quite big? Crashes your system, or at least brings your VM down. That's the sort of thing that they can do, and that's a denial of service attack, really easy to do. Okay? The hard bit are these things. They're called gadget chains. This is the way that most of these serialization attacks actually work. Right? So a gadget chain is a sequence of Java objects in your serialization form that you deconstruct. Sorry, you bring off the wire, and through these vulnerabilities that you've got, where we're going to drive some code, change some values, I find ways into your system. Right? This is a real one. Right? It's a gadget chain from read object, which is the thing that you obviously use to bring the data, the object through. So calling read object ends up going through this list of classes and methods down to runtime.exec. So I can now run code on your system. I can have arbitrary access to your system. Right? So you may look at that and you're going to say to me, it can't be that bad, really. Come on, serialization, that's really hard to do. How much effort does it take to build a gadget chain where you're working out all these little tiny vulnerabilities and how weaknesses in the code are bringing it together so I can exploit it? Because it looks pretty hard, doesn't it? Well, there's some good news. People write tools to do this stuff. This is the current one. There are others. This is a tool that you can go and get now. It's an open source tool. It will allow you to construct the serialized form necessary to do these attacks. And it's really helpful. Look, if you ask it what it can do, it tells you all sorts of payloads. These are all the different types of vulnerabilities that are out there. They're in serialized form. It's already got built in. Right? You pick it, Hibernate, Groovy, Closure, Bean Shell, Commons. They're already built in. So what I need to do is find a system with one of these versions of Groovy or Commons or whatever, that's where the vulnerability is, and attack it. Because I've got the tool to build the chain, I've got the data, all I need to know is what version number you've got. Okay? So let's talk about how that happens. Right? How do they find you? Well, they start with places like this. This is a website called showdown.io. Maybe we'll do a demo in a sec. This is a website that is an internet search engine that's designed to find IoT devices. So by definition, it finds every device on the internet. And it's quite clever, because it looks at the ports you've got, it looks at the software you've got, okay? So let's see, let me just pause this and we'll just flick over. Let's see if this will work. Where are we? Showdown, yes. So Showdown, let's put let's put port 1090. RMI port is something that uses serialization. Look, okay, I get lists of servers with, for instance, port numbers. They may not be RMI ports, okay, but they're already documented, okay? And I said about version numbers, well, look, I've got one here. If you can see that, X Jenkins 2.56. So I search this website and it finds servers that are running, here we go, a particular version of Jenkins. So why is that a problem? Well, let's go back to the presentation. Okay. Well, here we are. CVE for Jenkins version 2.56. So, serialization failure. So, I've got a tool that can exploit that vulnerability, and I have a tool that helps me find you if you're using that vulnerability. Think what I could do to your build systems if I've got remote code access to it. Okay? So, it's really easy to discover because we leak that data. And then we go, okay, well, what else can go there? How else can this be exploited? I'm showing you one tool, okay? You want to know more? How about this one? The exploit database archive, right? Exploit DB. all of the exploits that you can think of, right, for all these vulnerabilities are published. There is a whole set of people. Let me show you this. Let's try that one as well. Where's it gone? Exploit, yes, exploit database. Here we are. 40,000 exploits, right? There are just loads, right? So what does that mean? Well, if you look at any of these, pick an exploit, and look, there's code. People write tools, and this is all public, people write tools to hack your system, and they're shared, and they're connected to vulnerabilities. Okay. So I can go to this tool base and get all I need to do to make use of it, right? So if you want to do 256, there's an exploit for it. All ready to go. All I have to do is change the target URL, IP address, and I've got all the tools I need to do a remote code execution attack on that server. Okay, right? And to make it even more fun, there's a thing called the Google hacking database, which keeps track of Google queries you can do to find interesting things like files with passwords in, or web.xml, you name it. It can find all sorts of interesting information. Okay. So there's a whole bunch of stuff out there. There's a whole bunch of people who are building solutions to attack you. Serialization is just one of those, but serialization offers quite often the ability to do remote code execution. That's what people want to do, get into your system and run code. Okay. So you might go, who cares? It's really hard to do. So what? Who's going to do it? Why would the bad guys do this? Okay. So, let's talk about money, cybercrime. We worried about people hacking us. 20 years ago they didn't, now they do. Why? Well, we have the internet, but people have figured out how easy it is. 2016, cybercrime. Last year? 2 years ago, 2016. Cybercrime was worth $450 billion. The drug trade was reckoned to be worth less than that, just. So all those movies you see with people driving around in fast cars, all the drug-related movies, it's like, yeah, okay, well, the cybercrime guys make just as much money. Okay. Which one of these is going to have the least risk to the criminal? Cybercrime. You do not get caught for doing cybercrime. Right? It's growing the fastest because you don't get caught. Right? Right? It's impossible to prosecute people if you do capture them. It's really hard to do that because we don't have laws that let you capture somebody in one country for hacking another. We don't do all that, okay? But look at the money. The prediction is one of these is going to reach $2 trillion by the end of next year and $6 trillion by the end of 2021. Let's put that up. So a little chart. The red is cybercrime, the green is the drug trade. Look what happens. This is why talks about Java serialization need to be taken seriously. All security talks need to be taken seriously because as Java developers, this is becoming your problem. Because you need to understand that there's so much money in this, it is inevitable that you're going to get hacked. $600 for every person on the planet. And because of wealth distribution, that works out to be about, I think we worked out $8,000 in the US. Okay. It's not money that comes out of your account, it's money that gets taken out of the accounts of the people who provide you services. The governments, the banks, the insurance companies, the car manufacturers, they lose money and they pass that cost on to you. So personal cost to you is going to be horrific. You just won't see it there won't be a thing on the bill saying cybercrime charge. All your prices go up, right? And we do that, right? And one of the reasons this happens is because we're fairly ignorant as developers, right? We don't really think about security, right? Because I reckon you've all done something like this. I'm sure everyone at some point will say, yeah, I've Googled for how do I turn off security, right? How do I trust any certificate? because it's just easier than trying to figure out how to fix the problem. Right. How many of you done anything like this? Anybody going to fess up to having written one of these? Yeah, yes. It's easy, isn't it? You do this and your problem goes away. I say, so we've all done it, all the time. How bad can it be? Well, Git search, implement trust manager. Look what I found. 72,000 hits. Look at the nice words. A very friendly, accepting trust manager factory allows anything through. Install the all-trusting trust manager. It's funny, but remember this is on GitHub. A lot of this are in the code that you download with your dependencies. A lot of this, some of these, are actually features in products to allow you to turn off security. Okay? And what about if I do something like this? If I search GitHub for implement serializable, how much code is out there that's vulnerable? 10 million hits. It's really scary when you think about it. We have these great technologies that we write for our own good, for our good of our businesses, and for 20 odd years we've not had to worry about security other than big heavy things around the outside. But right now, it's important to realize that you've got to start looking at how you design applications and thinking about the consequences like serialization and other security implications, right? Because of this sort of thing. Right, wrap up. So, Java serialization is used everywhere. And even if you don't use it deliberately, you're quite likely to be using it because some of your dependencies is using it, okay? Right? And you can't escape because it's everywhere. 10 million hits, right? That's a lot. So the reality is, we've all got to wake up. This is talk about Java serialization, but as I said, it wasn't really about serialization. That's just one big example of the fact that the way that we think about our problems has to change. We have to recognize that security is fundamentally our challenge. We can't push it off to other people and go, yeah, put a firewall up. That doesn't help. Because there are always mistakes, and every mistake in a piece of code can be turned into an exploit, and it can be added to the list of ways to attack you. So you've got to start thinking about how you design code to make it be less vulnerable, right? Because the bad guys, they have no concern, they're just going to exploit you, and they're making so much money, right, out of our ignorance. So it's about time that we did something about it. Thank you. So I think I sort of finished on time. Any questions? So I can't see. No. Cool. Okay. Thank you. I'm around for the rest of the day. So if you want to have a chat, just catch me. Thanks.
Thank you.